Question number 5, probably the most difficult of your homework. 2D like no other, because first our plate is moving vertically, and then as it hits the floor, the pieces start moving in a totally different plane. Anyway, don't overthink this and treat this as an explosion. In other words, initial momentum of the entire system was 0 in both x and y direction. Therefore, momentum final x is 0 and momentum final y is also 0. So in the x direction, the third piece doesn't even have any momentum. So I'm only looking at the momentum that belongs to piece 2 and piece 1. Why do I know that they are equal and opposite? Because my initial momentum x for the entire system was 0, so the final momentum x for the entire system should be 0. How can it be 0 if I have 2? That means that they are equal and opposite, like 5 and negative 5. When I add 5 and negative 5, I'm going to get a 0. So my two momenta for the first and the second piece in the x direction are equal and opposite. So I might as well write it out as such. M1, 3, and this would be x component, so it's this way. So it's going to be through sine of 25 equals M2. Now in this case, if I'm looking at y, technically this right here is the vertical would be sine and the horizontal would be cosine, but sine and cosine of 45 is the same, so if you want to write sine, go for it, but I will stick to cosine of 45 degrees for x direction. Now, cosine of 45, I forgot the 175. Let me move it a little bit. One equation, two variables, unsolvable. I need another equation. So, hence, I'm going to go, this was my x direction, I'm going to go into y direction. What do we have going on in the y direction? We have two momenta that are upward and one momentum that is downward. And you remember from forces, if we have two upward forces and our object is in equilibrium, that means that our two forces that are directed upward add up to the downward force. Same thing with momenta here. We have two upward momenta, m1 times 3 cosine of 25 degrees plus M2, 1.79 sine of 45. The two of these together add up to the downward momentum, which is 1.3 times 307. There you go. Now I have a system of equations. I have two variables and two equations. It is very much solvable. Your options. Option 1. I can express M1 as M2. I can express M1 as M2. And then there is a ratio of 1.79 cosine of 45, which is a number. And then I will divide that by 3 sine of 25. And then I would divide that by 3 times sine of 25. And then I would calculate this contraption right here. And then drag this beautiful piece and plug it in M1 times 3 cosine of 25, blah, blah, blah. Solve the rest. Your option 2, express M2 as M1 ratio of 3 sine of 25 to 1.79 cosine of 45. And then you drag this and place it in place of M2 instead of M2 and solve the rest. So I will leave you at this because the rest of it is pure algebra. Physics is done. And you should get the right answers. Hopefully, we'll check when you turn in your homework.